So for today we are going to be going over reflections and translations. So a reflection, a notation for a reflection is a letter R with a little subscript of telling you what line you're going to reflect over. Sometimes they use a capital R and they tell you what line. It's not usual, but most times you'll see the lowercase r. So for example, if I write this, reflect over line L, triangle ABC. Oops, I don't know why I wrote line. If I say line L, I'll put it like a little cursive L. So it'll look something like this. So let's say this was my line. That's my line L. And here is triangle ABC. I'm going to just fix it up a little bit. Here's ABC. So if I were to reflect it over, every point has to be on the opposite direction, the same distance away. I kind of don't have enough room here, so I'm going to make it a little bit smaller. So the same distance away on the opposite side. So here's my C prime, here's my B prime, and somewhere over here should be my A prime, as if I folded over that line. And there's my reflection. Other examples that you might see is like reflection over the y-axis, or reflection over the x-axis, or reflection over the line y equals x. These are lines that you should recognize. So this is the y-axis right here. This is the x-axis right here. It's what you would fold over. And then the line y equals x is the line that goes like this. That is your line y equals x. So then let's take a look at an example. I'm just going to do a few here so you could see. If I want to reflect over this line in this first example, here would be A prime, here would be B prime, and here would be C prime, because I'm making sure every time that I'm in the same distance away from that line. So what would happen is that the line of symmetry right here, the line of reflection would look like the line of symmetry. So same thing here. Here's G prime, F prime, E prime. So I'm going a little faster than maybe your first time. It has to look like a mirror image when I'm done. Some people accidentally just move it or slide it. It's not enough. It has to look like a line of symmetry. Same thing here. So notice how I'm really trying to do one point at a time so that it ends up looking exactly like the reflection. See, now I did something wrong here. I could tell because it doesn't look like a mirror image. Looks like I kind of messed something up over here. That's because I did the points correctly, but M should go to L. Then L goes to this no-name dot, and then the no-name dot to M. See, now it looks like a mirror image, and that's a common error, what I just did. Instead of making it a reflection or a mirror image, I actually made it look almost exactly like the top. All right, and then number 4 is my last example for these kind of examples. Here's point N prime. And then notice if C prime is on the line of reflection, if it's on the mirror, it's not going to move. It'll stay on the mirror. And then O prime is right here. And then D prime is right here. It's on the opposite side. And then P prime has to be here. And then from P I go to Q prime, which is right there. So it looks like a line of symmetry when I'm done drawing it. Okay, so here are a bunch of other examples. I just want to show you really on a graph paper what it would look like. So here's point A. Point A is at -8 and -2, right over here. If I want to reflect that, it says reflected over the x-axis. Here is the x-axis. So it should fold over to the other side. Here is where A prime would be. Notice how the only value that changed is the y value. Here's another example, point B. I'll do it in a different color. Here's point B. Point B is at negative 1, 2, 3, 4, comma 2. And I want to reflect it over the y-axis, which is this line right here. So if I want to reflect it over, it should be on the other side, right here, at 4, comma 2. So notice how the only value that changed was the x value. So really important that you pay attention to what it says, because some of these say reflect over the line m. Some of them say reflect over the line n. So it's not only that the value of the sign will change, but sometimes the whole number will change too, depending on what line they give you. Okay? So even in an example like number 16, so if you see here it says reflect point A over line M. That's how you would read this. So this is the line that you're reflecting over. This is the object in which you're reflecting over. So here's point A, and I want to reflect it over line M. So here's lowercase m. So that shows me that this line is line M. If I reflect it over this line, at what point will I end up? I would end up at point C. So really important that you pay attention to this. I'm going to actually do this whole section. It says reflect point C over H. So I have to pay attention. Here's point C. Here's H. If I reflect over this line, it has to be exactly on the opposite side, as if I folded it over. It would end up at point B. I'm going to try and go, if you want to pause it here and try it yourself and see if you can get the same answers, that would be a great time to pause it. Reflect point D over line H, I would end up at A. What would I have to reflect over line G to end up at B? Here's line G. What do I have to reflect over that line to end up at B? Point A. Okay. And then I have to reflect D over line N. I would end up at B. Reflect B over line N. I would end up at D. Reflect D over line M. So here's point D, and I'm going to reflect it over line M. Now here's the thing, since it's on the line, since it's on the mirror, if I'm touching the mirror in the reflection, I should also be touching the mirror. So it actually is going to stay at point D. And then the last one, what do I need to reflect over line M to end up at C? That would be point A. So hopefully you got these answers. And that's how you complete a reflection. I'm going to skip some more of these examples. A translation. The notation for a translation is a capital T. And then you'd have two different examples of what it might look like. It might do X plus or minus something, comma, Y plus or minus something. So that'll tell you whether you're going to, move to the right or left. And this tells you up or down because X changes left or right and Y changes up or down. Or it might be written like this, where it'll have a positive or negative number there and a positive or negative number there. Or maybe I'll zoom in so you can see that. So that's really the notation for a translation. Now remember, a translation is move, right? So if I say translate, 3, -2 for triangle ABC. That means I want 3 units to the right and 2 units down. The reason why I know it's to the right and down is because X comes first. That tells me right or left, positive or negative. And the next one tells me Y. Positive or negative tells me Y. So let's say I had this triangle right here, and I labeled it A, B, C. I'd have to go 1, 2, 3 units to the right for every single point. So 1, 2, 3 units to the right. Oops, maybe I should fix that. So let's say it looks something like this. So I'm making myself a dot. This is as if I was on a coordinate plane, but I'm trying to give you an example. So if I want 3 units to the right, so everything goes 1, 2, 3 units to the right, and 2 units down. So here is my new B prime. 3 units to the right, 1, 2, 3, 2 units down. Here is my C prime, and 3 units to the right, 1, 2, 3, 2 units down. So here's my new A prime. So this is my new triangle, because it moved 3 units to the right and 2 units down. So we can always take a look. If they give us an arrow, it tells us the direction, or focus on, it's called a vector. It tells us what direction we're going. So to the right, 1, 2, 3, and down 1 unit. So it doesn't always provide this. It always will provide, or almost always will provide, the notation. So every point goes 3 units to the right and 1 unit down, and 3 units to the right and 1 unit down, and 3 units to the right and 1 unit down. Notice it should look exactly like the figure that you started with, called the pre-image. It should always look like what it started as if you want to do it correct. This one says 1 to the left, 1 down. So every point should go 1 to the left, 1 down. And that would be your new image. So notice how it looks exactly the same shape and size. Okay? So really I just want to make sure you understand that. So take a look here. It says translate x plus 3, y minus 5. So if I do plus 3 and minus 5, I'll end up at -1, +2. That's my new coordinate. Same thing here, -7, -1. I would end up at 2, 0. Notice here I have to add 1 and add 6 to end up getting a 4, -1. So really, if I want to go backwards, let me go backwards, subtract 1 and subtract 6, and I'll end up where I need it to be. Because 3 plus 1 gives me 4, and -7 plus 6 gives me -1. So if you need to go backwards, you should do the opposite of what it asks. See, look at number 5. It says -2, or -5, +2. That means do x plus 5, it means do x minus 5 and y plus 2. 4 down means we're doing a -y, and 3 to the right means we're doing a +x. So it should be x plus 3, and it should be y minus 4. When I say left, that should be a -x, and when I should say down, it's a -y. So I have x minus 7 and y minus 2. When I say to the right 1, it should be a +x, so x plus 1. And then it doesn't say to do anything with y, so I just leave it as y. So really that's translations for you. Translations are a lot easier because you're just moving them on the graph. It's more about counting the spaces and in the right direction. So if you have any questions, please make sure that you ask, and have a wonderful day, everybody.